Okay, did anybody find any patterns? We're going to call this first one Chart 1. And notice that we have the two numbers that we said it was between. The square root of 2 falls between 1 and 2. So we went between 1 and 2. Did anybody find a pattern in the x squared column? Casey? We're squaring each number. We're taking 1.1 and we're squaring it, and we're getting 1.21. We take 1.2 and we square it. So we're squaring each number. Did anybody see between each of these numbers, was there a pattern there? Between 1 and 1.21, what's the difference between that? 0.21. So we're adding 0.21. Between 1.21 and 1.44, what's the pattern there? 0.23. You're exactly right. What do you think the pattern is between 1.44 and 1.69? Two hundredths. All I'm doing is each time I'm adding 2 hundredths. There is a pattern within this. So would I actually have to go through and do all of the squaring to find out? I may just have to go and do 2 or 3, find out what the pattern is, and then I could continue to fill out the rest of the column. Okay? Let's look at our other paper now. If you could go and grab this one. This is the On Your Own. We're going to actually give it a try. We're going to see if we can do the first chart and see if we can actually find out where the square root of 19 falls between. Now it says estimate it to the nearest hundredth. I think I typed that out wrong. It should be to the nearest thousandths. So if you want to change that. On my notes it says thousandths, but I think my fingers did the typing and they weren't listening to what my brain was saying there. We're going to estimate the square root of 19 to the nearest thousandths. First of all, where does the square root of 19 fall between? It's going to fall between which two whole numbers? Well, but which are the two perfect squares? If I were to find the square root of 19, the perfect square that's less than 19 is, or we could say 16. Once we find the square root of that, it's 4.
Isn't it 18?
Why isn't it 18? That's a good question. Because 18's not a perfect square. Why does it have to be a perfect square? Excellent question. Why are we only looking for perfect squares? Dalton.
It's kind of like estimating. We're around estimate. We want to get whole numbers because it's easier.
We want to get a whole number. We want to find the two whole numbers that it's going to fall between. The square root of 16 is 4. So the next perfect square bigger than 19 would be 25. So when we take the square root of that, we know that the square root of 19 is going to fall between 4 and 5. Now if we look at to fill out the first chart, just like they did on our notes from yesterday, they started from 1 to 2. What are we going to have to start with? Where are we going to?
4 to 5.
We're going to start with 4, and we're going to end up at 5. Because we know the square root of 19 is going to fall somewhere in between here. Dalton.
Should we go ahead and put like 16 and 25 on the other side?
We can put 16 and 25. Yep. And if we look back to what this anonymous person did, how did they fill out the rest of chart 1? They added the tenths to it. So instead of 4, we had 4.0. Then we had 4.1. This is the test to see if Mrs. McCabe made the table big enough. Oh boy, did she?
Yeah.
Yes, I did. Hallelujah. Now, why we're needing to do this is we're wanting to see the math behind it. We know the calculator can do this. And so obviously if they're asking us to approximate this, they're wanting us to try to figure this out in our head. So that's why I have no calculators allowed, because we know the calculator could do this in a heartbeat. How am I going to find what 4.1 squared is? That's not as easy as 4 squared. What am I going to have to do? What does 4.1 squared mean? Multiply by itself. Notice all of this extra room over here? Okay, we can easily just take 4.1 times 4.1. Now, if you use the lattice method, I'm perfectly fine with the lattice method. If you use the traditional method to multiply, you may do that. This will give us just a quick little practice on multiplying. So let's go ahead and get our answer down. I've got 2 decimal places, so I need to have 2 decimal places there. 16.81. Now what I'm going to do, I'm going to use a different color here. I'm going to see if there's a pattern here, because the minute I can find a pattern, do I have to keep multiplying? Okay, so we're going to be adding 0.81. I put my work a little bit too close, but I think I can squeeze that baby in there. Does anyone have a hypothesis of what you think the next one's going to be? What do you think we're going to have to add? Well, what do you think the purple adding would be? 0. Point what? If we base it off of our chart here. Okay, so that's what we can hypothesize. I wonder if it's going to do the same exact pattern as the first one. Well, let's check it out. Let's take 4.2 times 4.2. Should we see if it works? If it is 0.83? Were we right? At this point, would you have to keep doing the multiplication? At this point, no. Could we fill out the rest of this? What's going to be my next one that I would add?
18.49.
So I would add 0.85. Okay, so we can do that over here. 17.64, 0.85. .85, yeah. Now, if some of you feel more comfortable multiplying and finding the perfect squares, that's the other way you could do this. You could take 4.3 times 4.3. That's what's so cool about math, is there's so many ways, and once you start to really dive in and start to see what's happening, you can pick and choose how you need to go about through this. Now, have we gone far enough? We're between 4 and 5. Have we reached 19 yet? We're getting closer. We're getting really close, but I already can tell I may have to do a couple more. So what I'm going to have you do is I'm going to have you finish up this chart, and let's find out the 2 numbers that it's closest between in chart 1. We never did label this chart 1, so that way we know it goes with our first chart. So go ahead and finish this up, and let's see where our 2 numbers are at.